So, good afternoon, everyone. We are delighted to welcome you all for the session 11 of day 4 in our ongoing faculty development program. It is indeed an honor to have you yet another accomplished speaker to join us for this session. To begin the proceeding, and I'll invite M.K. Nanmaran ME to deliver the welcome address and offering a brief introduction of our distinguished chief guest, Dr. S. Barathi, Associate Professor of SSN College of Engineering. Please continue, sir.
It is my pleasure to welcome you all to this event. We are honored to have with us Dr. B. Barathi, a distinguished academic with over 25 years of teaching and research experience in the field of speech processing, natural processing, and machine learning. Dr. Barathi earned her BE degree in 1998 from Arulmigu Meenakshi Amman College of Engineering, Madras University, followed by an ME degree in Computer Science and Engineering in 2006 at SSN College of Engineering, Anna University. She was awarded her PhD in Computer Science from Anna University in 2014 for her doctoral research in speaker recognition. In recognition of her dedication to teaching and mentorship, Dr. Bharati has received multiple Best Teacher Awards from SSN College of Engineering for the years 2010, 2011, 2012 to 13, 18 to 19, and 2020 to 21. She is also recognized a PhD supervisor at Anna University with the recent doctoral candidates completing their degree under her guidance. Throughout her career, Dr. Bharati has made significant scholarly contributions, authoring over 70 publications in prestigious international journals and conferences such as Springer, and securing competitive research funding totaling several lakhs for projects in speaker verification, anti-spoofing, speech emotion recognition, and IoT-based smart systems. Please join me in warmly welcoming Dr. Bharati, whose extensive experience and scholarly excellence in speech and language techniques will undoubtedly enrich our discussions today.
Thank you. Am I audible?
Yes, ma'am.
Yeah, thank you. Okay, thank you so much for the nice introduction. And today's talk, I'll be talking about, or I'll be giving the hands-on session on natural language processing task. I think today morning you have had enough introduction about natural language processing. So I'll just touch upon with the basics and I'll directly go to the hands-on session. I'll share the screen now. Is the screen visible?
Yes, ma'am, visible.
Yeah, okay, thank you. Okay. So today's outline of my talk is to understand what is NLP and its significance and explore the core NLP task which will be used in industry perspective also. And we will deal with some hands-on session on few NLP tasks, how to implement those NLP tasks. And as you all know, the NLP is nothing but natural language processing, which combines the language information that is called as linguistics and computer science, as well as the artificial intelligence concept. So it what it will do is it makes the machine to understand what we are talking or what we are writing, and it will generate the informations as like a human language. And there are many applications of NLP, so translation, chatbot, auto correction, spell checker, automatic speech recognition, and so on, etc. Summarization, and so many NLP tasks are there. So we will be dealing about a few tasks now. And what is the role of NLP in Industry 5.0? So here there are very many applications which are implemented in industry, and where you can use NLP concepts to do so those tasks. For example, here human machine collaboration. As you all know, we are also using so many human computer interaction things in our day-to-day life. And here in order to suppose if you have a smart home, And in order to switch on your fan or light, we will be using voice commands. So here in the mission also, so if suppose if you want to, smart car also has come up. So there we will use voice command to operate your system. So they are voice activated commands for smart machines. And here the machine cannot understand only one language, so it should work for many language, because as in India we have a multilingual speakers are there. So the system should understand, and it should communicate with so many languages. So it should support multilingual communication interfaces should be there, and conversational AI for intuitive machine control. So here conversational AI in the sense making conversation between the human being and the machine. If I ask any question, the system should respond. Similarly, this again, if I ask other question, and system should respond. That is a way of conversation. So conversational AI is nothing but we will be interacting with the system as like a human being communicate with each other. So there we will be using NLP. That is, in order to make the system, in order to build a conversational AI, you need NLP concept. Similarly, if you want to do some multilingual communication, there we will need NLP. As well as if you want to implement a voice activated command, where we will be using NLP. NLP is nothing but it is a mode of communication. It may be through text message, or it may be a voice command. So NLP is combination of speech as well as text. And the next application may be cognitive automation. So suppose in the intelligent document processing, so you have so much of document, and if you want to retrieve or extract a few informations or extract the relevant information from the document, where you can use NLP concepts. And automating unstructured data processing from reports, manuals and emails. So there if we want to do the automation of automatically you want to generate some reports from the given data, where you can use NLP. And streamlining the workflows and decision making, we will be using NLP. And here suppose if you want to empowerment and upskilling the workforce, so where we can use NLP based learning assistance. Okay, so here there are so many learning platforms are there. So there we have used people have used NLP concepts to implement those learning assistants. And real-time support for troubleshooting and maintenance, and personalized training using natural language interfacing. Suppose if I don't know the programming language called a Python, so in that case I can have an interface where a training environment where it will teach me the NLP or the Python concepts. So if I do some programming and if I made any error, then it should indicate it is not like a compilation. So it will produce, it will give the explanation where I have made a mistake and how will I correct that. Those informations can be given by the personalized training environment that we have developed for any programming language, say like Python. Similarly, we can do it for anything, not only a programming language, even for if I want to learn a new language, say like Tamil. So there I can have a Tamil language interface where I could how to pronounce the Tamil words or Tamil letters, as well as the sentences and so on, where I can use this. And sentiment and emotion analysis. So we want to analyze the employee feedback and the communication, where we can use this NLP concepts, enhancing the workplace well-being and productivity. Early detection of stress and disengagement can be obtained. So from the that is from the conversation of the employees, we can collect those feedbacks, and from the feedback you can analyze whether it is whether the employee is conveying a positive sentiment about the particular topic or negative sentiment and so on, whether the employee is happy or sad or anything. So those things can be analyzed from these NLP concepts. And predictive maintenance and quality control. So here extracting the insights from the technician notes and sensor log, so where that is possible. And predicting failures and improving the equipment reliability. And here NLP enhanced diagnostics can be made. So in order to ensure the quality control of the machines, so from the sensor log we could find out the that is it is early prediction of failure could be done using this. So thereby you can enhance the productivity. and knowledge management. So you can do semantic search and question answering systems, summarizing the technical document and procedures, and preserving the expert knowledge across generations. That could be possible. So these are all the role of NLP in industry perspective. And now we'll come to the NLP task. I think a few of the tasks that you have heard in the previous session. Just I'll say what is the meaning of each of these tasks, and we will see how to implement few tasks in this. The first task, very basic task, is text classification. So you can classify, you can categorize the text among any one of the classes. It may be a binary class or it may be a multi-class. Suppose if I have a text or the text comes from an email, and from the email message, I need to identify whether it is a spam message or not a spam message. So that is an example of text classification. Similarly, I may have a document where I could identify what may be the emotion present in the given document. It may be a emotion, may be an happy, sad, or neutral, or angry, and so on. So where I could analyze the text and I should identify what may be the possible emotion present in the text. Okay, so that is text classification. And text generation. Text generation in the sense you can generate the text. As you all know, almost all of them we are using text generation tool. Can you say some example text generation tool that you are using? What text generation tool have you used? Am I audible? Please respond. Am I audible?
Yes, ma'am.
Yeah. Okay, thank you. Okay, so the text generation tool that we are using is ChatGPT. So where you can generate text. Suppose if you want to generate any particular information on any particular theme, so you can generate a text. And information extraction. So from the given document, if you want to extract some relevant information which you are seeking for, so that could be done. And machine translation. Machine translation is the task you can translate the text from one language to another language. Say it may be from English to Tamil or Tamil to English and so on. And then next one is question answering. Question answering is you can ask the system to any question and the system should respond to the particular respond to the question. So where in the question answering it may be a context based question answering you could use. So or that is a domain specific. Suppose if I want to ask the question only which are related to related to Am I audible?
Yes, ma'am.
Yeah. Is the screen visible?
Yes, ma'am. You
Okay.
may proceed.
Okay. Yeah. Sorry, some interruption. Uh, okay. So I am talking about the NLP task. I think I don't know where I have left. So I'll just repeat. Text classification is the process of categorizing the given text into any one of the class. For example, here the for email spam classification, you can classify the email text as either spam or not spam. And the text generation is the process of generating the text. So here nowadays all the that is generative models are there. So one of the example for text generation model is the GPT models, or that is a chat GPT, where you can generate the text. And next is information extraction. That is you can extract the relevant information from the big document, text document, and from that you can extract the relevant information from that. And then the next is the machine translation. Machine translation is the process of translating the text from one language to another language. That is machine translation. And question answering, that is you can ask any question and the system should respond to the answer. And next is conversational AI. Conversational AI is a two-way communication. So we will both-way communication will be done. We can ask any question to the system, or ask question, or we can respond to the question asked by the system. And that is conversational AI. And next is text to code. So here you can generate the programming code by giving the question in the natural language. So that is, for example, a Copilot. So where you can generate the code with that. Even ChatGPT also could do that. And text correction and enhancement. So you can do the spell check or grammar check and everything in from the text, and you can thereby you can enhance the text, the quality of the text content. So that is done by all the GPT models also. And multimodal task, that is you can instead of using a single modality, say like a text, you can use multi modalities like speech, text, as well as visual content. It may be a video or image content. So from that you can do many tasks. For example, visual question answering, that is you can show a photograph, and from that photograph you can ask any question. It may be a medical image, or it may be a natural image. So from that you could ask any question from that, and the system should respond, or the system should generate the answer for that. And domain specific application, so instead of generating a generic application, you can develop a domain specific application. For example, if I want to summarize any document, or only summarize the document from the scientific report, so where I'll be training the model only with the scientific scientific papers alone. So there we will be summarizing the data only with the specific domain. And retrieval augmented generation, so this is another recent method. People are using RAG. RAG is nothing but you can generate the text not only from the given domain content that we have developed. Apart from that, it will also use the content which are available through the outside world, that is through internet, and it will combine both, and it will give the appropriate answer for that. And then compliances and moderation, education and learning, all these places where you can use this NLP concepts. And applications of NLP. So here, virtual assistant, as you all know, Siri and Alexa are application of NLP only. Spam detection, sentiment analysis on social media, legal and medical text analysis. It may be a legal document, or it may be a medical document. You could do some analysis on that. And machine translation, as you all used Google Translate, which will translate text from one language to another language. And automatic text summarization. So you can summarize the given big document into small document. There are many other than that. Okay, so here we will just elaborate as I said, and here we will have some example and for each of the NLP task. So here the text classification. So it could be at sentiment analysis, or it may be at topic classification, or it may be a spam detection, or any intent classification. So here we will have some question, and based on the question, it should analyze the sentiment. The sentiment may be positive or negative sentiment, or it may be a neutral also. And then here, if you want to do some topic classification, I'll have some text, and whether it is related to technology or whether it is related to health or entertainment and so on. So here, based on the content present in the text, and it should identify the topic corresponding to the text. And then here, as I said, the spam classification or spam deduction. So based on the given text, you should identify whether it is spam or not spam. For example, congratulations, you have won a lottery. Click here to claim your prize. So this is obviously a spam message. So the system should identify whether it is a spam or not. And then intent classification. So what is the intent of giving that particular text? So here, book a table for 2 at 7 p.m. So this is for booking. And whether what is the weather like today in New York? So here it is a query. So the intent should be identified or detected based on the text information. So here we are categorizing the text based on the context which we are asking for. So that is the text classification. And the text generation. Text generation is used in many use cases, like a creative writing. That is, we'll be giving the prompt, write a short poem about the moon and ocean. So here the system should generate a poem about moon and ocean. So creative writing, summarization, report generation, and so on. Or code generation also. Suppose if I want to generate a code to generate a Python code to perform or to find a factorial of a given number. So in that case, the text to code generation is there. So here, these are all the use cases for code generation or text generation. And information extraction. Information extraction, the use case may be named entity recognition, that is NER. So I think morning class you would have heard about these terms. So here, given the text, you need to identify whether the word belongs to, word may be a noun, or it is a name or a date or location and so on. So that is named entity extraction. And relation extraction, that is, we want to find out the relationship between the entities. So first we need to identify the entity, and then we need to find out the relationship between the entity. That is relation extraction. And another use case is key phrase extraction. So from the given text, you have to highlight or you have to identify the most important phrase from the given text. And then extracting the structured data from the unstructured text. That is, from the figure or a table, you need to identify the relevant information, required information from the given table or figure. That is a table or text extraction. And machine translation. Machine translation is translating the text between different languages. So here, English to Tamil and so on. And here, domain specific translation. That is, you can customize the translation for specialized domain, like legal or medical or technical text alone. That is, what is the advantage of using the domain specific translation is, you will be generating the model that could work only for the particular domain. So you will be training the system using only the data related to the particular domain. So that is the domain specific translation. And the next is question answering. Question answering is mainly used for FAQ, that is a frequently asked question system, and contextual question answering, or domain open domain question answering. For example, that is you have seen many bots in the websites where you could ask the question related with the website or anything, and it could able to answer your question. So that is question answering system. And conversational AI. Conversational AI is a chatbot and customer support, automating the query responses to customer inquiries, and virtual assistant, where you can use this NLP concepts. And text to code. So here you can generate SQL query from the natural language. That is, here get the names and ages of all the employees from the employee table. So here I don't know about how to write a SQL query. So here I'll be giving my question as a natural language, and then it will generate the SQL query, and from the SQL query I can get the relevant answer from that. Okay. So where you can use this SQL query generation and code explanation. So here we will be giving some code and it should explain the code, because I have generated the code from the system, and then I don't know what is the meaning of each of the line present in the code, and I need some explanation about that. And here the code should be given to the system, and the system should explain the code snippet in the layman's terms. Okay, it should understand for everybody. And debugging assistance, generating fixes for broken code. Suppose I have compiled my code and it will generate the error, and I need to find out the error, what type of error, and I should fix the error, so that I can have a debugging system that will do that. And text correction and enhancement, as I said, it is a grammar and spell checking, correcting the grammatical error in the text. And a style transfer, adapting the text to specific tone or style. It may be a formal or informal. And paraphrasing is rewriting the sentences while preserving their meaning. So you can that is, you can give some sentence and we can ask the system to rephrase it or paraphrase it, and it will rewrite the sentences without changing the meaning of the particular text. That is. And till now we have seen what is NLP and what are all the possible NLP tasks that you could do. Now we will see what are all the possible NLP tools, libraries and frameworks which are available. Okay. So here the tools may be, these are all the few tools: Spacey, NLTK, Transformers, Stanford NLP, and Open NLP. And here the Spacey, NLTK, Transformer, these three tools are developed, or you can use Python language to get the to use that particular tool. And Stanford NLP and Open NLP, these tools are based on Java. And here in the Spacey tool, it is mainly used, it is fast, and it is industrial strength and NLP libraries are available, and it is used in the academia as well as the industry perspective. And the NLTK toolkit is it is mostly, it is developed for research purpose, and it is a research focused NLP toolkit. And in the transformers, there are many pre-trained models are available. Transformer models are available. Transformer model is nothing but actually it is a encoder decoder architectures are used, and there are many pre-trained transformer models are available to perform various NLP tasks such as classification, summarization, question answering, and so on. Okay, so for all those tasks, there are pre-trained models are available. Just you can import those models and we could get the answer. So that is transformer models which are available. And Stanford NLP, it is a very standard tool which has been developed in earlier. And the language used for developing this Stanford NLP is Java, and it could do POS tagging, part of speech tagging, so which will tag the given text into noun, verb, adverb, and so on. Okay, so that is a POS tagging could be done, and parsing can be done. Parsing is to check whether the given text is grammatically correct or not. So that is parsing. And even you could do sentiment analysis also. And open NLP is, it is a ML based NLP tool. You could do all the learning can be done using this open NLP toolkit. And the next is what may be the pre-trained APIs and models are available for doing the NLP task. That is OpenAI GPT model. So GPT can do text generation, summarization, conversation, and so on. And it is a cloud-based tool or API. And Google Cloud NLP, so where you can do entity recognition and sentiment analysis. And it is actually an API tool, and you could enhance or you can it can be scalable. And IBM Watson NLU, natural language understanding. So here it will do emotion recognition, keyword extraction, sentiment analysis, and do on. It is enterprise ready version 1. And Amazon Comprehend. Here it will do entity recognition and topic deduction and so on. So it is Amazon Web Service integrated one. And Claude and Coher is for text generation and so on. Okay, so here it is alternative for large language model. It is similar to large language model only. And another few NLP tools, that is a speech text integration. You want to convert that speech into text, where you could use few tools. One is a Whisper. where it is high accuracy speech recognition tool. You could generate, you can convert the speech into text. And speech brain is another toolkit. It is actually a multitask system. So here it will do speech recognition as well as speaker recognition and so on. And WASC is a lightweight offline ASR system. So here using you can that is you don't you need not need much computational efficient system to implement that. It is a lightweight automatic speech recognition system could be developed using this. Another toolkit is Kaldi. Kaldi is also may used for research purpose, and all the speech related tasks could be done using Kaldi. And the next is Quacky STT, speech to text toolkit. It is supported by Mozilla Deep Speech. And now we'll move on to the hands-on session. And we will be going to see a few classification tasks, as well as how sentence generation task, as well as question answering and summarization task. We will see how to implement all those things. So I'll go to, and I can share all these Python notebook as well as um, data set through the WhatsApp group message, group WhatsApp, and there you could download and upload it in your Google Drive, because we are going to use Google Colab to implement that. Okay, so now I will upload all the codes in your uh, WhatsApp. Hope you have received the uh, content, right? Is the contents are uploaded? Is my screen visible, ma? Any one of you please answer. Is my screen visible?
Yes, ma'am, it's visible.
Yeah.
Yes, ma'am. That's visible.
So now first we will see a classification task. So we are going to classify the given text offensive. So I have shared this Python notebook Assoc, hate speech and offensive content identification from the Indo-Aryan language. And it was published in a FIRE task forum for information retrieval task. And I have just used that particular data set for showing this demo. And here you can, what you have to do is you have to download this Python code and upload it in your Google Drive. And here we will be using this particular training data also, en underscore Assoc 2021 train.csv. So here we have to upload this CSV file also. Okay. So here this CSV file contains the information about the text as well as the corresponding label. I'll let you know what are all the information which are present in that. And before that, we have to first task is we need, hope you know how to use this Google Colab. I'll assume that you already aware of how to use Google Colab, and directly you can upload that code into Google Drive. And when you open with the Google Colab, then you can open that in this particular mode where you can first cell which contains importing the libraries for the classification task. So here we are going to use the tool called sklearn. Sklearn is also another NLP which will be performing all the machine learning and other task for text based as well as other numerical based classification and other things. So here we have to import all the necessary libraries. So here I may be using the MLP classifier, multi-layer perceptron classifier, or logistic regression, random forest classifier, k nearest neighbor, and support vector mission, and so on. Okay, so if I want to use this, so I need to import all these classes. And then here, as you all know, in the machine learning, so we need to, these are all the three in the machine learning pipeline. These are all the three machine main tasks. That is, from the given data, you need to extract the features. From the extracted feature, you need to train the model, and then you have to predict the given data. Okay, so that is the pipeline. So here, these are all the classifiers I am going to use, and I need to extract the features from the text, because the system will not understand the text present. That is, I cannot give text as such. I should somehow I should convert that text into some number. So I need some feature extraction method. The very basic feature extraction method that is used in NLP is count vectorizer and TF-IDF vectorizer. Okay, so this if I want to use these feature extraction method, then I should import that. Okay, so feature extraction dot text and import these things, and then I need to do some performance analysis. So here I should use performance and generating the report. I should use confusion matrix, classification report, precision score, recall, and F1 score, and so on. And here these pandas, numpy library, and other things and all, if I want to do some accessing the data from the CSV file or TSV file or Excel file, then I should consider that as a data frame where I should use pandas. And if I want to do some numerical analysis, then I should use numpy array. And TQDM is for seeing the progress bar. That is an optional, you can omit that. And then here, for this is for cross validation. I will let you know what is cross validation in the subsequent things. Okay, so the first thing is I need to import all the necessary libraries, and then here my data will be in the Google Drive. So I need to import or mount the drive. So here these two lines for mounting the library or mounting the drive. So from google.colab import drive and drive.mount content drive. So for the first time user, it will ask for the credential. So then you should choose the appropriate Google account, and then you should give permission for that, and then the drive will be mounted. And then the drive is mounted. Then now you have to read the data from the drive. So here, this is a CSV file. CSV file is comma separated file where you have the training data, which will have the training ID and the text and then corresponding. This is how it will be. So here, this is the sentence ID or sentence number, and then here you will have a sentence, and then you will have a class label whether it is an offensive or not offensive and so on. So we need to identify, we need to classify the given things. Okay, so here I'm loading the training data. So PD for pandas object PD dot read underscore CSV, and then I should give the path for the training data. And then here I'll be doing some pre-processing. So I want to remove some special characters from the given text. So I'll just declare all the special character, and if I have any special characters in this text, and I should replace that with the space, just I'm removing it, that's all. Okay, so I'll be removing all those things. So that is a simple pre-process. You can do like this, or you can write a regular expression to remove that, and here the NLTK toolkit will support that also. So you could write the regular expressions and do so, do the same. And then now I need to extract the text as well as the corresponding label. Okay, so here train is the variable where I have already read the data, that is the train is the label, and which will contain the text as well as the label. Okay, so I have column names. So where uh, the text is the text column name, and the task underscore one is the label column name. So using the column heading, I will retrieve the data. So train of text comma train of task underscore one. So here train of text will give you the text, which is stored into train, and the train of task underscore one will give you the label, and which will be assigned to y underscore train. And here just I will be printing this train and train size, since it is a very large file and it is printing only few lines, and the number of rows present in the given data is 3844 lines. And then here there are two labels, offensive and not offensive. So here these are all the number of um, offensive. We have 2501 text samples, and not offensive 1342. Okay, and then here we are going to use three feature extraction method. One is count vectorizer, and next is a term frequency inverse document frequency TF-IDF, and then sentence transformer. We are going to use these three feature extraction method to do the classification task. What is count vectorizer? Count vectorizer is from the given text, it will identify that into frequency representation, the number of times that particular word or string is present in that. So it won't see the context or semantics, just it will count the number of times that particular word is present. So number of times the particular word is present in the sense that may be an important word that could be useful, but you need not bother about the stop words like and the and all. So here this may be present in so many number of times, but that is not going to be used for using this feature extraction. Okay, so here the advantages, it is understand the type of the text and the frequency of number of times the particular word is present. The disadvantage is it is inability in identifying more important and less important words for analyzing, because it doesn't know the context. So it is not possible for the feature extraction method to identify the important and less more important word and less important word, and it will well, just to consider the words are abundant in the corpus as the most statistically significant word. If the word is more number of times present, then it will assume that that is very statistically significant word, and as well as it won't find out the relationship in the words. So this is the disadvantage of using count vectorizer, but it is usually it will work fine for most of the cases. Okay, and here you know what is count vectorizer. Now we should know how to extract those count vectorizer. You have already imported the corresponding library, then you should use the function count vectorizer analyzer equal to character, that is character based count we are going to use, and n-gram is 1 to 3 gram, 1 comma 3. And here just we are defining the object, and we have to use the function vectorizer dot fit transform of train. Okay, so here we will be passing the training data to fit transform function, so which will convert or which will vectorize the given text into count in the vector form. Okay, so now x underscore train will be the features which are extracted from the training data. Okay, and now we don't have any test data separately. So what we will do is we will split the data into train and test. So from the sklearn, we'll have a model selection class, and in that you will have a train test split method, and where you could specify x underscore train, x underscore train is that feature extracted training data, and y underscore train is the corresponding label. And here we should specify the test size. So here the test size mentioned as 0.20, which means that 20% will be used for testing and 80% will be used for training the model. And then random state is seed. So here, since it is a train and split will be in the random manner, so every time you may get a different type of test data and training data. In order to avoid that, you can fix the seed value. So if you use the same seed value, then you may have a same set of training and test data. So we are splitting the data into training and test data. And then now the data is ready. We have done the feature extraction, and we have splitted the data into training data and test data. And using the train data, we should train the classifier or model. So we may be using support vector machine. Support vector machine is a discriminative classifier where it will find out the discriminant function to discriminate each of the classes. Okay, offensive and not offensive. So it will find out the support vectors. So the data points which are closer to the corresponding support vector, it will be classified accordingly. Okay, so now we have to import the corresponding classes, corresponding library, support vector machine library from sklearn import svm. And here svc is the method where you have to specify the kernel and cost function and so on. There are different kernels are there, linear, polynomial, and Gaussian functions are Gaussian kernel is there. So you have to define the corresponding kernel here. Okay, so here for in this example, we have defined the kernel as linear and cost function as 0.01. Suppose if you are not using any of these values, then it will take the default value which has been defined for this particular function. And then model dot fit. The fit method is for training the data. So here for fit method, you need to pass the training data as well as corresponding label, and the model will be trained and which will be stored into the name object name called model. Okay, so when the model is ready, then we should do the testing. We have already splitted the data into x underscore train and x underscore test. So x underscore test will be the test data, and you have to use the predict function to predict the class of the given test data. So model dot predict of x underscore test. So the prediction will be available in y underscore predict, PRED. Now we need to find out the performance analysis. We have to do the performance. So performance is mainly based on accuracy, precision, recall, and F1 score. Okay, so where you can use the classification matrix function or classification report. So for classification report, we should pass the actual ground truth value, the original label, and then the predicted label. So y underscore test is the ground truth label for the test data, and y underscore predict is the predicted label. Both could be passed to classification report, and which will generate the precision, recall, F1 score for each of the classes, and accuracy is 77%. And here confusion matrix also you can generate. So 418 data will be classified correctly and 68 will be misclassified as other class. Similarly here 175 will be classified correctly for not offensive case, and 108 will be misclassified. So accuracy is this much. Okay, so this is for svm. So here I didn't do any parameter fine tuning, so you could do parameter fine tuning to improve the performance of this task. And the next technique is cross validation. So here instead of using the entire training data for training and remaining for testing, so here in the cross validation what you could do is you can reserve some portion for sample test data, and remaining data will be used for training, and then the reserved data set data will be used for testing the model that has been trained so far. Suppose if I have a five-fold cross validation, and the entire data will be divided into five sets, five subsets, and one subset will be used for testing, and the remaining four will be used to training. And for the next iteration, some other another subset will be used for testing, and the remaining four will be used for training. So which will make the system, that is, it will build the model consistently across other training data. It will not be mostly biased. So you can do the cross validation to get the better model. And here we will see the code for how to do cross validation for another classifier, say example multi layer perceptron MLP classifier, and where we will be using some parameters, that is the number of iterations. Maximum number of iteration is 5, and the iteration number, some maximum iteration is 5, and if there is no change, you can do, if there is many changes are there, then you could have 10, and hidden layers are 128. And we have to use cross validate is the function where you should pass the object of MLP classifier CLF, comma, training data and training label. And here I will be using number of fold is 5, cross validation fold is 5, CV equal to 5, and the train return score is true. And then here we will that is, this is for cross validation, and it will return the score as cross val score. You have to use this function to return the score, and from the score you can print the accuracy. Okay, so here here also you have to use pass this function, and we have already trained the system, and it is generating the accuracy as 77%. And this is for MLP classifier, and the scikit-learn support many machine learning classifiers, so you could use any one of the classifier and to validate your system. So here this is for k nearest neighbor, k nearest classifier, and here we have to mention the number of neighbors as 3, and use cross validate as well as cross val score. Remaining things are same, only the machine learning function should be changed based on your need. Okay, so this is for extracting the count vectorizer features, and then we are training the model. And next is TF-IDF feature extraction, term frequency, inverse document frequency. Okay, so here TF-IDF is the metric to determine how significant a term is to term in the text in a corpus. So here it will check for some significance of the particular word that is not counted in count vectorizer, but here where that is number of times the particular word is occurred, and how many number of documents that particular word occurs will also be considered. So here it will find out the word's significance in the given document, that is for TF-IDF. So we'll see how to use these things. So here this is the function vectorizer, TF-IDF vectorizer. On that is instead of count vectorizer, I have just used TF-IDF vectorizer. Remaining will be the same. It is a character based vectorizer, and the number of n-grams will be 3, and so on. And vectorizer dot fit transform of train. So training data will be given, and TF-IDF vectorizers are generated, extracted, and then from the extracted feature again I'll split the data into training and testing data, 80% for training and 20% for testing. And then I'll use the same SVM classifier, and then I'll do that. And here the performance accuracy is 63, and the same MLP and k nearest neighbor and so on. Okay, so here in the among the above two, I'll use the same classification method, text classification. In the first method, I have extracted the count vectorizer, and then from the extracted feature, I have built different models, say like a support vector machine, k nearest neighbor, and MLP classifier, or random forest also you can do. And other one is I have extracted TF-IDF vectorizer, and then I have used all the machine learning models. And this is the second method. And the other one is you can use sentence transformer. Sentence transformer is one way of getting the embeddings. Embedding is in the sense it will use some semantic meaning, and it will find out the corresponding vectors for the given text. So that is a sentence transformer. There are many pre-trained models are available. So you can check with this particular URL. There are some many pre-trained sentence transformer models are there. So what you have to do is you have to download these sentence transformer model, pre-trained model, and then you have to pass your text to that particular model, and then you should find out the encoding or embeddings of that particular test sentence. And using that particular encodings or embeddings, you should again build a model, build a machine learning model, and then you should find out the performance. Okay, so in order to do so, what you have to do is you have to install the sentence transformer. So pip install sentence transformer. So the sentence transformer is installed, and then here I'm using Indo-Aryan XLM R base. So this is one of the pre-trained model which is available. Then I will use that. So sentence transformer of the transformer model should be given, and then here I need to find out once the model has been taken, and I need to pass our text and find out the encoding or embedding of the given text. So here we will be passing the text. Text is nothing but our text which are extracted from the CSV file, and that should be passed to this model.encode of. It will encode the given text, and here we will give the batch size as 50 and show the progress bar as 2. So that is why it is the progress bar is shown here, and it will we will get the x underscore train will be the transformer based embedding of the given text. So that is x underscore train, and which will be used to train our model. The remaining process remains the same. So here we will be using MLP classifier and cross validate, and we will pass x underscore train in the previous cells. X underscore train shows the first example. It shows x underscore train is nothing but the feature extraction, or the features are count vectorizer which are extracted. And then the next method, we have used TF-IDF vectorizer to extract the features from the training data. And then here in this method we will use we have sentence transformer to get the encodings or embeddings of the given text data. And then here and then y underscore train is for um, label, and cross validation is CV fold is 5, and return train score as true, and then we will train the system, and then we will get the accuracy. And similarly you can do it for k nearest neighbor and so on. Instead of using this model, you could check for the performance using various other pre-trained models, and then you can get the embeddings, and then you could build the model. And one more embedding is also there, glove embedding. So here that could also be used here. Glove embedding can be used, and you can generate the model and could see the performance. So this will be the simple classification task that could be using the very basic methods, as well as the advanced method like sentence transformer encodings are there. So you can even you can use a BERT embedding and other embeddings. Suppose this is, if it is for English, you can use this. Suppose if I want to do it for Tamil text classification, so in that case you have to use the corresponding pre-trained model is there. So that will support a multilingual BERT model is there. MBERT is there, multilingual BERT, and XLM is for cross-lingual or multilingual embeddings that could be used to get the encodings of the given text data. And then you could use this machine learning classifier and do the classification. And one more thing is also there, you can use the BERT model. BERT is also an embedding. So using the BERT model itself, you can do the classification also. Instead of using the encoding, get the encoding and then train the machine learning model, what you can do is you can use the BERT itself as a classifier, and there you can do the classification. So this is for the classification task. So here that is, the training may take some time, so that is why I didn't train it. So if you want to do so, so you can click each of the cell and then see the performance, and you can vary, you can download the data and you can upload it, and then you can vary the parameters of each of the classifier. Here in the classifier I haven't changed anything, just a few things I have used and a few things I have used the default values. But instead of using default values, if you want to use your own values and if you want to change it, and you can change it and then see the performance differences, then you can do. So those who are beginner for the NLP task, NLP domain, what you can do is you can start with the classification task, and then you can go ahead with the other task like say the summarization and question answering and other things. So classification may be simple for the beginners. Okay, so this is for Indo-Aryan task. And then the other one is here the Tamil model is there. Is the screen visible? Hope this screen is visible. So here multilingual Tamil BERT LBTQ Python notebook. So here also this is for offensive language, where here this is the data which is given, LGBTQ Tamil data, where this is for non-offensive and offensive. That is for Tamil text, not in English text. So here the Tamil text. So here using this, you can do the you can use the Tamil BERT to do that. So here instead of using TF-IDF and count vectorizer, here we have used a BERT model to do that. The beginning portion and all the same. Just we'll mount the drive, and then we will upload the data. Data is in the Excel form, and we have uploaded, and then just we have printed the number of classes. Actually, only two classes, non-offensive and offensive, because of the spelling mistake in the data set with the label, and it is showing 4 classes, but actually only these 2 labels are only one sample, and you could rename it, and then you can make this as 2 class classification. Okay, and then here number of samples in each of the unit which is shown. And here the pre-trained model here we have used is bird based multilingual case. So here it is a multilingual model, and which will support Tamil also. So we are using the pre-trained model as bird based, this one. And then we are using the Tamil data set, and here we have the length of the embedding as we will fix the number of characters or number of that is the length of the embeddings as 256. And then here this function is for loading the data, and where we have to specify the encoding, whether what type of encoding you want to use, what type of attention you want to use. All those things should be given here. And this is for loading the data, where you should specify what type of tokenizer, length and batch size and everything should be you mentioned. So here this is for a default function which are already available. You need not worry about the code, because this code is already available for fine tuning your BERT model. Okay, so here just to use these methods which are available. And what we have to do is we have to give the batch size based on the RAM size. We have to give the batch size. Here I'm giving the batch size as 4. And we are going to use create a data loader. For data loader is for loading the data, and where we have to pass what type of tokenizer, what is the maximum length and batch size and training data and so on. Df underscore train is for the training data which are extracted from the Excel file, and df underscore test is for test data which are extracted from the Excel file, and which will be loaded here. And the Tamil classifier here, this is also the class which is already available, where we have to pass only the pre-trained model name. So pre-trained model that we have already defined, it is a bird based multilingual model, so that we have to pass it. And what the remaining configurations files are, which we have already defined in the classifier, that could be used here. Okay, and then here we will be using CUDA function is available. Suppose if the CUDA is available, then training will be faster, and we will check whether CUDA is available. If the CUDA is available, that will be GPU will be used, otherwise CPU will be used. And here we will be giving the number of epoch as 2, and we need to fix the optimizer. Optimizer is Adam optimizer, and we will be using the learning rate and other things. So these are all the, you can directly use this. And then here model dot train, for training this will be the function which we are calling model dot train. Train method will be called, and the data will be loaded, and a training will be done. And in order to evaluate your model, we have to use eval model, and where we have to pass the trained model and the data that would be loaded, and then last function and other things. So it will give the predictions. And then here this is for for training data and the training function, though here the training has been started, and it will print the training loss and accuracy, validation loss and accuracy. So after the number of epochs are exhausted and model has been trained. And here for prediction, you can use get prediction, and where we will call the eval function here, model dot eval, where we have to define again what is the text and what is the input id, target, and everything should be given, and it will return the predictions, prediction probability, as well as real values will be passed. So which will be stored into void underscore data text, that is the test data text, and then the corresponding prediction probability, and then the test data, actual test data labels will be given. Okay, so here using this you can get the classification report using the same classification report which are available in the scikit-learn. So you can have a precision, recall, F1 score, and accuracy. So here the accuracy is 92%. Okay, so this is for Tamil text. So those who want to use the Tamil text, and if you want to use multilingual BERT, then you can fine tune the model which is available here. So this is for fine tuning it. Okay, so this is for classification task. I think there is a time for break, and we'll break for now, and then we will connect after 10 minutes. Okay, we will go to the next task. Am I audible? Am I audible?
Yes, ma'am.
Okay. Okay, next is sentence generation. So first task we have seen classification task. So where we have classified the English text as well as Tamil text into various classes. So now next is text generation task. So now we will see the some GPT models. So because of this space constraint, we have used a GPT-2 model. So it is for generating the text. So first I'll show how to use the pre-trained GPT models, and then we will see how to fine tune the GPT model for your own task. So here we will see the first GPT-2 model. So it is available in different forms: small, medium, large, and Excel. And each one will have different attention modules. So based on the small, if it is small, then our number of attention module is 12. GPT medium will have 24 modules, and large will have 36, and Excel will have 48, and the distill version will have it is a lighter version which will have a lesser parameter than the other. And in order to use this GPT-2 model, we have to install the Hugging Face transformer and as well as a TensorFlow 2.1 version. So we need to install these two, and then we have to load the GPT-2 model. So in order to load that, we have to import the necessary files, necessary transformers as well as a TensorFlow, and then we have to load the tokenizer as well as load the model. Okay, so GPT-2 tokenizer from pre-trained GPT, and as well as the corresponding model will be loaded. So here the loading has been taken place here. And then here, in order to generate this sentence, different decoding strategies are used in GPT models. One is greedy search, beam search, top case sampling, top piece sampling, and so on. So first one is greedy search. As you all know, so greedy is the search method which will take the best case on each and every step. For example, whenever I have a first word as the, and the probability of getting the next word as dog, nice, or car as with these probabilities 0.4, 0.5, 0.3, and 0.1. So here among these three probabilities, sorry, not 0.3, here 0.1. So among these three words, so nice will be having the highest probability. So then the next word generated will be nice. So the nice will be generated. After nice, what may be the next possible words? There are three possibilities. One is woman, house, and guy, and these probabilities are given as 0.4, 3, and 3. Okay, so here the highest probability will be 0. Woman. Okay, so 0.4. So the nice woman will be generated. Similarly, for each and every step, it will check for the highest probable word, and based on that, it will generate the next words and sentences. Okay, so for example, here I want to generate the text based on the text which I have generated. I enjoy walking with my cute dog. So this is the text I have given, and based on this context, I need to generate the remaining words or sentences. Okay, so here I am giving model dot generate model which we have already loaded, that is GPT-2 model, and then here I am giving the input text as I enjoyed walking with my cute dog, and then this will be tokenized and which will generate the tensors for that, and which will be stored into input IDs, which will generate the tensors, and the indexes are stored in input IDs. And then these input IDs will be given to model.generate, and it will maximum length as 25. It will generate the text until it reaches the output length, which includes the context length also. For example, here I enjoy walking with my cute dog will also be considered here, and and if it reaches 50, then it will stop it, and it will decode the word and it will print it. So here the output will be I enjoy walking with my cute dog is the context which we have given, and it will generate the text as but I am not sure I will ever be able to walk with my dog. So this is a sentence which has been generated by the GPT-2 model. So the context is given, based on the context, and it will generate the next possible words, and it will possible sentences will be generated based on the length we have given. So this is for greedy search. So here The limitation is the model quickly starts repeating itself. High probability words are hidden behind the low probability word. So that is the limitation here. So high probable words are placed behind the low probability word. So that will not be detected. So which will the same words will be repeated again, because those words only will be having the higher probability. So those words will be repeated. So that is the limitation of greedy search. And here the beam search will be used in the GPT-2 model. So here it will see the multiple sequences, and based on the multiple sequences it will choose the best sequence with the highest probability. So here the dog has, which has the probability 0.4 and 0.9, and the nice woman has this one. So here this will be having the higher probability, so the dog has will be chosen. So it will consider the not only a single word, multiple sequences will be considered, and based on that highest probable sequences will be generated. So here, in order to activate the beam search and early stopping, we have to give this. So input IDs will be passed, that is the word that we have given as a context, and maximum length, number of beams will be given, early stopping will be true. So then it will generate the sentences like this. So this will be the sentences which are generated. And suppose if you want to do not to repeat the sequence that starts with the same n-gram, I don't want to repeat the same sentences, then in that case I should give no repeat n-gram set size to 2. So it should be given. So if I give like this, then the sentences will be generated like this. And to return more sequences, so here I should give more sequences, number of returns as sequences as 5. So then 5 sequences will be generated. Different things will be slightly different way. It will generate 5 sequences. And then if you give a top case sampling only, it will produce the first top 5, how many ever k value you are giving. So that many value of sentences will be top k sentences will be given. And here the k value is 0, so it is generating this like this. And you can have a top k to decrease the sensitivity to low probable candidates, then you should give temperature as 0.7, so to reduce that. And similarly the other methods are there, just go through. Because of lack of time, just I'll skip only these two, top k and top p sampling, where you should set the parameter accordingly, and then it will generate the sentences. So this is for GPT-2 model, and here we are not doing any fine tuning, and we have directly used the pre-trained model which is already available, and then we have given our own context, and based on the context it is generating the sentences. And if we want to generate we want to fine tune it for our own data, then we have to we'll see what are all the steps involved in fine tuning the sentence generator sentence generation model. So for what you have to do is you have to upload the data set, because for articles.csv file I want to give, and I should upload this data set and pre-process the data set if you want to do anything, and extract the textual content and load the data set for tokenization and create the batches and apply padding. Suppose in order to make everything an equal size, and we will be applying padding or truncation, and set the parameters and train the model and save the model and load the model for generating the text. And here we are importing the necessary libraries, and then here we are cleaning the text. So here we are using the regular expression to find out the words and any special symbols, and those things will be replaced or removed as by the space. So here we are using the regular expression to do so. So we have to pass the sentences to this cleaning function, which will clean everything, and then it will, that is all the HTTPS and the symbols and the backspaces and everything will be removed. Backspaces, white spaces will be removed. And here this is the function definition, and we will be calling the function in the subsequent cell. And here read CSV file, we are reading the CSV file. And then here not defined columns will be dropped, and then here the which will be converted, we will have a text file and open it in the write mode, because we will read the data and which will be written into articles.txt, and we are calling the cleaning function. We will pass the article and data will be clean. And here we will import the transformer model. We will import the transformer, and we will import all the necessary GPT-2 tokenizer and head model and everything. We will just import it. And then we need to do the tokenization. In order to load the data set and do the tokenization, we will define the function load data set, and here we have to pass the file path and tokenizer and block size. And here we will define everything, and then it will load the data. And in order to create the batches and padding, we have to use load data collator, where we have to pass the tokenizer, and we have to call the data collator for language modeling, and tokenizers that we have to mention it. And then here we will use the accelerate and other things and all. And then here this is the function for training, where we have to define the function, and we have to pass the training file path name and as well as the model name and output directory. So here we will use model name is the model that we are going to take it initially, and the model will be fine tuned with the data set that we are passing, and then the fine tuned model will be written into output directory. Okay, so that is what which is given, and here we have to specify the batch size and number of epochs, and the save steps will be mentioned here. And here we will be calling the in sequence, we will be calling the we will be loading the data set, and we will be applying the padding and all, and then we will call the train function, and then we will save the trained model into output directory. Okay, so here these are all the functions, where here we will define the trainer equal to model, argument and data collator and so on. And here we will trainer dot train, which will this function will call the train method, and then save model, which will save it. So here only we will be passing the parameters to this above functions. So we have to set the path for the train file articles.txt, and model name is GPT-2, and output directory name is result, and then batch size is 8, and number of epochs is 1, only one epoch giving, and save steps 500. And call the training function. So here we will call the training function. We have already set the parameter, and we will pass the parameter to the train method. And here the training has been done here. Only one epoch, and the steps is 500. So after 500, the training loss is displayed. After 1000, it is training loss is displayed. And here once the model is trained, and which will be saved, and we will load the model, and we'll have the tokenizer for generating the text, and here call the text generation function. So here generate text sequence comma max length. So here we will give just oil price 100, and it will generate the sentence like this: oil price cut and uncertainly is something. So it has been generated like this. Okay, so here output for oil price with a 10, oil price with a 100 sequence length for trained for one epoch is like this, and for 5 epoch it will be better than that. Okay, so this is how you have to train your own model, your own GPT-2 model, fine tune your own data, and then GPT-2 model will be fine tuned to generate the text which is related to your own task. So this is for text generation task. In the text generation, we have seen two files. One is how to use already existing pre-trained model, and then the next one is how to fine tune the GPT model for your own custom data. So that is for GPT-2. And then the next is for summarization. So you can use you can give your own data, and then you can summarize it. So we will see existing here also the same thing, that is you can use T5 model, text to text transformer model, which is for translation as well as summarization, question answering, everything can be done. And there is a variation which is called as MT5, which will use multilingual variant of T5. So it will extended to multiple languages. And M2M is for many to many translation or generation task. For example, English to Bengali or Hindi to Urdu, and so many things can be done. And cross-lingual summarization can also be done. Okay, and here we will directly use the summarizer name and the pipeline as summarization, and then whenever you give a text, and it will give the summary text. So summary text will be generated. So whenever you use the model name, and the model will be loaded, and then it will generate the summary of the given text. So here artificial intelligence is one of the world's most sophisticated technologies, but here we have given the text as a big paragraph, and that will be summarized into a small sentence using the pre-trained model here. So this is how you can use the pre-trained model. And this is also on another way, another MT5, and again we have used the same model, and then we have demonstrated with another example. And then in order to see the performance of summarization score, you can have a rogue score. Rogue score will give you the information about how the quality of the generated summary with the existing summary which is available. Okay, so here in this example we have used a data set, the data set which contains the English heading, and then summary, and then the article. Okay, so this is the data set which is given. So what you have to do is you can use the existing this is the data set train.csv file. And here for this CSV file you will have an article, and this you have to generate the summary for this article, and you have to compare your own generated summary with the existing summary. But here in the previous example we have given a single one paragraph, and then from the paragraph we have generated the summary. But here we are going to give a long CSV file which contains different articles, and each article will have its own summary, as well as heading will also be given. So these things will be given to the pre-trained model, and it is going to generate the summary. And then what you have to do is the generated summary will be compared with the summary which is given. Okay, so this is the data set description. And then here we are using the pre-trained model to generate the summary. Okay, so here the generated summary will be printed, and generated summary is this one, and the original summary is given. And here you can use the rogue score, create the function to calculate the rogue score, which will print the rogue score as like this. So precision, recall, and F1 score. And the same thing is done for Tamil data also. So you can use the Tamil data, and then you can generate store the model. That is, it is a multilingual model. So you can use load the model, and then pass the data and generate the summary. So the generated summary is like this. Okay, so this is for text summarization, and then you can find out the rogue score. Okay, so since here the English Tamil is not supporting that much, so here the rogue score value is 0.0. And here this is for you can the last file is for fine tuning your own model. Okay, so here till now I didn't fine tune the model, just I have used the existing model, and then we have just generated the summary. But here you can load the model, and then you can give your own data, and the target text will also be given, and then you can fine tune the model. So you can load the transformer and everything, all the training data, configuration files, everything should be given. This is similar to what we have seen in the previous GPT-2 models also. The trainer data and everything should be given, and then you have to pass our own values, and then you have to fine tune it. So fine tune these JSON files, and then it will generate the summary. Okay, so this is for fine tuning the summarization based on your own custom data. So this is all about the hands-on session. So here in the hands-on session, we have seen three different tasks. One is classification, the other one is question answering, and then the other one is summarization. In the classification, we have seen how to classify data as well as Tamil data using different models. And then the GPT-2 models, we have used how to use a pre-trained model and how to use fine tuning for our own data. And summarization also, we have seen how to use the pre-trained model and how to do fine tuning for our own data. So that's all about from my side. And if you have any doubts, you can ask me now. Do you have any doubts?